Is your, where is your guy? This is your. He won't go to John Brand. The two, the yours, but what is the French? This is the French.
Yeah. Praise.
Okay. So, come to this, and
It's not on.
okay. Okay, so welcome to this small announcement session, which is to let you know when will be the next AICC conference, which will be in 2027 and not 28. So the first one was in Paris in 2023. The second one was in Strasbourg, in Beta at the European Parliament, and in Munster for the symposium. The third one was in Lausanne. There are some people from Lausanne here at EPFL and Zinal. This year, you are all enjoying Frascati, and now it is time to think of the fifth conference, which will be in June 2007. And I let the floor to the remote presenters who could not make it to come here this year. Suspense.
Have always had a strong interdisciplinary cooperation, even if they have so far been oriented quite strongly toward economics, public policy, and collective decision. This year, an important bridge has been built with development studies. AICC believes that it can further strengthen both the engineering and the international dimensions of this community by hosting our 2027 conference at the Hamburg University of Technology, the TUHH. Whether we speak about adaptation or mitigation, engineering sciences bring an essential, though of course not exclusive, dimension to the climate debates. Infrastructure, energy systems, transport, cities, networks, and technologies will all be central to the transformations ahead. The objective is therefore not to replace one perspective with another, but to deepen the dialogue between economists, engineers, urban planners, climate scientists, and public decision makers. Hamburg provides a particularly appropriate setting for the scientific and international cooperation. Beyond its industrial power and its smart green port, it is a city deeply connected to its environment. proving that major metropolitan centers can actively engineer a sustainable green future.
Engineers are usually part of the solution when it comes to climate change. Yes, we may have been also part of the problem, but the question is, what can we do to maintain our style of living and to not compromise too much? We build bridges, in theory, but also literally, because bridges are the things which enable us to bridge between different domains, different technologies, different disciplines, and come up with better solutions. Engineers, by definition, learn how to do that, and this is what we live at TUHH. You can have good ideas, but the ideas themselves are not sufficient. Usually you need also something to create impact. The collaboration with the United Nations, as well as Hamburg University of Technology, was a key to both create visibility of our activities and also to be networked in the global environment. So the United Nations were convinced of our contribution to their global goal. And we were convinced that with their help, we can actually see and maximize what we have in our mind. We are now looking forward to expand our network, is contributing and boasting your countries. See you in heaven.
The research on sustainable topics is the clear focus of Hamburg University of Technology. One of our focus topics is engineering to face climate change. It means that we develop methods and technologies to mitigate the followings of the climate change. And this is what we do with the mechanical, chemical engineering, and all aspects of the science and technology in our university.
Hamburg is ready to bridge the gap between climate science, economy, and real-world engineering. We look forward to welcoming you all at the TUHH next year and to inspire your journey. Now, let's take a look at what awaits us in Hamburg for AICC 2027.
So this was the part of the team who will organize the next conference, and they prepared for us a few images from the city.
Hamburg, a major European metropolis of nearly 2 million people. Yet, step closer and you find a city defined by its balance, where over 16% of the urban landscape is dedicated to green spaces and public parks. But this isn't just nature preserved, it is sustainability engineered. Here, industrial power and ecological responsibility exist side by side. From massive green hydrogen initiatives to a deeply electrified smart port, Hamburg is actively testing the blueprint for a carbon-neutral future. South of the Elbe lies Harburg, home to a centre of rigorous scientific application, the Hamburg University of Technology, the TUHH, an institution explicitly driven by real-world impact. As a designated United Nations university hub, the TUHH doesn't just study global challenges, it directly shapes engineering solution pathways for the UN Sustainable Development Goals, from clean energy grids to climate adaptation. A global gathering made simple, with seamless international connections from Hamburg Airport and a single quick transit transfer at the city centre. The Harburg campus is within easy reach for our global community. This makes it the perfect ecosystem for our next step. Following our momentum from 2026, the action versus inaction facing climate change initiative is converging right here. Over 3 days in June 2027, the AICC conference comes together to bridge the critical gap between knowledge and execution. The diagnosis is behind us. The path forward is about implementation, breaking down barriers, and deploying real-world operational solutions. See you in Hamburg. See you at AICC 2027.
Okay, so This is it. The people from Hamburg were so desperate they could not make it to come this year, but really they are still working very hard on preparing the next event, which will be in June, and they will be happy to welcome you. Thank you. We don't know exactly the dates. It will be to fit your constraints, Moshe. It will be either beginning or end of June, but we will check with you to make sure that you can make it.
Okay, I would like to open the session on transport development and CGE. So being the last presenter of this session, I'm also the chair. And I'd like to invite here Kay Axhausen. Oh, yes, that's great. Thank you, from Zurich. Please. Can. Up.
Okay, for something slightly different from the papers and presentations I've seen so far, this is the product of a substantial joint collaboration effort at ETH Zurich, where we tried to look at what could we do if all the current policies to achieve net zero or much reduced CO2 emissions in transport. And where is the beeper? Oh, I need this. Thanks. Anyway, so I'll talk about the dilemma, and then I will talk how an e-bike city might work. And I should be more precise. It is an alternative, not in general, but for urban areas. I don't want to make too big claims. Now, if we look at, and if you talk with people, what is the dilemma which transport planning has? Because when you look at policy making, it is mostly business as usual. Policy, oh, let's build a road, let's build a railway, and that's about it. And that can't be true, that is really the way forward in current times. So what is the dilemma? The dilemma, as far as I understand it, is that we had an incredibly successful past 70 years. And these 70 years have essentially forced us to maintain current policies. What do I show you here? I show you Switzerland in 1950, but not in kilometers, but in travel time. Those who know Switzerland a bit better would say that the Engadine at the east and the Jura in the northwest are a bit further than they should be, and that the Valais is also a bit out of scope. So this is Switzerland in 1950. If there's questions how we did this, I'll explain that later on demand. Now, this is 1950, and now look at Switzerland in 2000. That's the same scale. Essentially, the investment in roads and cars has shrunk the country by a factor of 2. On the railway side, it's not quite as massive, but equally substantial shrinkage. So we have changed our environment massively, and we now know, and economists have shown that again and again, and planners as well, that this improved accessibility, which comes from that shrinkage, is improving our productivity in all kinds of ways. And that is the dilemma now. We know that our past policy has worked and is very popular, but we are now facing the fact that the side effects, the externalities, weren't fully accounted for and now catching up with us. So what to do? So what do we do? So we do know that accessibility and increases in accessibility improves economic productivity. That has been shown, not endless, but many, many times. And I would argue it increases and stabilizes our social capital as well, because these smaller countries allow us to maintain our contacts in a much more way than we used to. Now, this is what we want, and this is why politicians just want to do business as usual. Now, but we also know, and have shown that this is the case, that this higher accessibility increases car ownership, the prevalence of car ownership. It increases transport demand, and with it, greenhouse gas emissions. And because we are building our roads slower than we want to drive, it increases congestion. It encourages working from home. And in the Swiss context and general context, that will reduce the willingness to commit yourself to public transport. So increasing the willingness to travel by car even more. And it obviously invites sprawl. So people will move out. And depending on the country you're in, there are already legal limits. And Switzerland in particular has given itself a law which limits sprawl. It has given itself the laws to reduce greenhouse gas emissions, and on and on. So what do we do? What can we do? Now, it's not as if transport planning isn't thinking about that, but we also have to now worry about additional issues. There's planning for resilience. Now, in the morning, we talked about flooding, but how do we plan the networks so that they are both not encouraging further sprawl and are still resilient, so have backup, spare capacity, which is normally not an idea to not generate new accessibility. And obviously, we have to now plan under the constraints which are given through the greenhouse gas laws we have, our societies have given themselves. So how can we do this, all of that? Now, what are the possibilities? I will not show all of them, but obviously here there are enough economists who would say this is what we have to do. We have to price the use of the cars. And this is kind of nearly a complete list of what planners and economists would like to price properly. You would have a two-part tariff for the infrastructure. So essentially one tax on the car and then pay as you go for usage. You would then charge for congestion pricing so that it doesn't even happen, or it doesn't happen as badly as it could. You would have demand responsive parking prices. All of you, I guess, know the work of Donald Shoup. As that, you would then price greenhouse gas emissions, and then you would price anything else which is an externality. And all of you know that if you put this forward as a policymaker, you're voted out of office. If you look back at the cities where at least the congestion pricing was brought in, these were very specific circumstances which allowed the policymakers to get it through. Let's say Ken Livingstone got it through because he was voted in as a response to the Conservative Party, and therefore he could sneak in congestion pricing for London. If you look at Stockholm, they essentially only asked those people who benefited, i.e. the people living inside the city and not the people outside the city. If you look at Singapore, the Singapore government didn't care about public opinion. They just wanted to have the image for the rest of the world that they are modern and working. So not many countries in which you have those conditions. And if you add all the other things, it's not going to be a winning program. So what do we do? There is obviously discussions about mobility budgets and mobility coins, but all of these are essentially pricing by another name. And I'm not sure that that will be very popular to be implemented. So that doesn't look like a progress. Then obviously building more railways, fair enough, if you have billions. And many countries don't have those billions. And even if they have them, those investments take ages to come to fruition and are not really active and usable for 2040 when we are supposedly reaching our net zero goals. So something else has to be thought of. And that was the starting point of our project. And the project was, now, not yet. if you hold that for a sec. The project was a collaboration of 6 chairs at ETH departments of civil engineering and environmental engineering. We are brought together by this basic idea, which we wanted to test. And the idea was, what would happen if we give 50% of the road space in the urban area to bikes and e-bikes? We wanted to find out how that would work. And could it work? Could we make sure that all the addresses were still reachable by motorized vehicles, that the accessibility levels wouldn't go down massively, and what would be the impact on behavior? So that was the starting point. And we then had a bit of money to also produce a video about the results. And now, please.
Climate change may be the greatest challenge of the 21st century. In Switzerland, transportation produces 41% of CO2 emissions from energy combustion, which is more than in the USA and across the European Union. Traffic jams are commonplace, and by 2050, populations in Swiss cities should grow by another 30%. Traffic simulations by researchers at ETH Zurich show that there is a solution to increase the capacity of streets and reduce emissions. Reallocating more street space for sustainable modes can improve safety, efficiency, access, and sustainability in a way that everyone's mobility needs are met. Decarbonizing transportation while improving the freedom of travel requires integration of micromobility and public transportation. By transforming streets, we can strengthen public transportation and micromobility and provide safer and more attractive spaces for pedestrians. Emergency and delivery vehicles, as well as mobility vans and tradespeople, will have access to all buildings through a parking reservation system. Better access to wider, separated bike lanes will increase safety and convenience for all ages and abilities. Children can enjoy cycling to school safely. Increased bike parking and more publicly shared micromobility would provide last-mile connections for commuters and visitors. More space designated for micromobility means people would benefit from less crashes, reduced stress, and improved health and well-being. Based on research, redesigning streets is a quick and cost-effective solution that would work if implemented. People can regain autonomy and enjoy the freedom of movement without owning a car. By combining public transport and micromobility, we occupy less street space and make the city more livable for everyone while achieving emissions goals for transportation.
If you go to the next slide, please. Okay. Now, this is the vision, and we produced the video, we produced plans for all of Zurich. Okay, Zurich is not that large, it's 450,000 inhabitants, but we have a network plan to look at the impact. Now, when you do something like that, you obviously ask, okay, what will happen? And what we did do, we implemented MatSim, which is our agent-based microsimulation, which we had already in place. We expanded it and added the new network. And then we looked at what the behavioral response would be. We had also done interviews about public acceptance, and that was about 40%, 45% in the city of Zurich. So what would the people actually do in terms of behavior? So one of my PhD students, Lukas Meide-Freitas, implemented an SP survey, and you have a view here of the interface. So people responded on the trips they did in a selected day. Then based on those trips reported, we then showed them the today and the future scenario to give them an idea how that world would look like as best as we could, given the constraints and budget and time we had. Now, and it's interesting, we then, obviously, we estimated the mode choice models and the other choice models to implement inside MatSim. And then, we looked at, okay, what happens? Well, if you implement all those changes, what is the impact? people see. And this is after the first iteration, so before equilibrium. And what you can see is that the travel times for the car drivers go up massively in the peak hours, nearly doubling. And you would assume that that signal does something to their behavior. And it did, as you would expect in the model. And what I show you here are the mode shares after the change has been implemented. And what is interesting to point out is that we had two mode choice models. One was the model estimated on the SP, and one was the model based on the RP data we had as well for Zurich. And with the current behavior, the changes aren't as massive as you would expect, because people haven't accounted for all of the change in the environment, the better feeling of safety, the friendliness of the environment. All of that is missing in the current behavior. So you need to mix at some level the current and the future, likely future behavior. And you can see that the changes are massive, that people get out of their cars, they effectively go to public transport, in particular those on longer journeys. You have more walking and more cycling, as you would hope for and expect. We then, or Lukas then did a cost-benefit analysis using the existing Swiss norm, and the benefits are massive. So the cost-benefit ratio is nearly 10. So the project really would be worthwhile doing. Now, you can argue, okay, but do we believe this? In particular, do we believe the responses in the SP? And there's obviously more work which needs to be done. But on the other hand, and Moshe is probably the best witness to that, SPs do work. So they tell us something about the future which we wouldn't otherwise guess. And with that, I can start to close, and happy to have questions. And here are all the publications and the website of the department, which has all the projects, all the partial projects, which are done in this 3-year project. And with that, I'm looking forward to your questions.
Thank you very much also for the timing. Very nice.
Okay,
Any
thank
question?
you. I have just
Please.
sent you a paper that deals with this kind of deployment at city scale of bicycles. But my question was 2 questions. First one, what do you mean by changing behavior or not changing behavior on this last slide? The other question is, by comparison with what we did, is that when you put bicycles, there is a benefit. You have less congestion, less emission, and so on. But you make intersections when you develop, for example, bike lanes, you make the intersections more complex. And the net benefit could not necessarily always be positive. And what we find in our simulation that we increased progressively the share of the bicycles until 15%. You have small changes. Sometimes even you lose some welfare. But starting from 15%, you start getting more and more benefit that increases. I think at 40% of the trips made by bicycles, you remove a large part of the emissions. And
Okay, I think the first question I would have in your case, whether you were as radical as we were, because in essentially what we did, we gave 50% of the road space. So half the street space was given to the bikes. So essentially we ended up with a massive system of one-way streets. So the car drivers obviously had some extra congestion, but they had also longer distances involved. So that, it would be really interesting to look at your work, but I think one part is that, because when you do that, you address one issue which bicyclists always report, and in particular those who aren't yet bicycling but might, that they are afraid of the cars and the other vehicles, and that the bike lanes aren't enough. Bike lanes aren't enough to produce that feeling of safety. And our argument would be that you really need to give them a lot of space. And that comes back to your first question, because your current behavioral models still have the feeling of lack of safety embedded in their parameters. And only if you estimate the models on this new world, you can get people to feel safe in the new environment. And that would be my second argument. But I'm looking really forward to look at your
Okay, I've
papers.
already sent it, but what do you mean? So this is what you mean by change in behavior? Or
Yes.
not? So, okay.
Yes. And you?
Just two very quick questions. One, did you consider urban logistics in your model? Because it's clear that they are not going to go away. We heard yesterday that vans will be there anyway. And so having just one lane, one-way streets may cause severe delays to the rest of the road traffic. And the second, did you take into account rain? I mean, the weather. I mean, all your movies were with sun, but expect that in rainy days, the willingness to use bike is going to decline.
Okay. The weather argument always comes, but when you look at the empirical data today, you can see that the rain impact isn't really that large. It's there, but it's not killing it off. And even if you look at winter data, it's maybe goes down 10, 15%. Yes, it's an impact, but it's not really an argument. Now, the freight logistics is a bigger issue, I agree. Now, it was really interesting to see that our price paper talked about cargo logistics with bikes. So they would really be happy with his solution. And I think that would be the next step. But having said that, we didn't really simulate it properly, and we should do. But I guess I would simulate a solution like his to be compatible with the urban environment.
I have the microphone.
Yeah.
This is more of a comment, but in the video that you showed, it talked about fewer accidents, which I'm sure in Switzerland, that's the case. I spent a lot of time in New York City, which in some ways has become an e-bike city, but it's one in which everybody is in fear of the e-bikes. And most of them are delivery drivers. I'm sure the Swiss I know the Swiss are much more well-behaved than Manhattanites, but it's just, it's a frightening place to be a pedestrian. That's all I would say. So I'm sure it's a very different scenario, though.
I think it's a fair point, and I think this requires more work. But I would really be interested to compare it with the Paris experience, which is another big city, which has also delivery drivers as well, but a different social environment. So I would really like to look at that. I haven't really seen much French work on this issue, but maybe it's just because I don't read French or not good enough to enjoy this.
Hello, thanks for your presentation. I'm just interested in getting how did you change the behavior in the model? Does it mean that you changed the utility function attributes? And so you have two calibrations, one which is in red and light green, and the other one which is in green?
Yeah. I know, I think the variables stay the same. So we're talking about travel time, cost, blah, blah, blah. But the SP data gave us new behavioral observations. So we estimated that model on the decisions taken in the stated choice experiment, which I briefly showed you. And the light green is based on the RP, on the observed behavior in Zurich. So it's two different parameter sets, but same variables.
Okay, so the red is the reference.
As a reference, that's as it is today.
Light green is with the project without any behavioral change, and green with the project and the behavioral change.
Yes.
Do you have the data if you change the behavior, but you stay without the project in reference?
We didn't do that, but we could. It's work because we have to run MATSIM, and we didn't do that. But it's a fair point.
Okay, thank you.
There's a question in the back. Sorry, wait a second.
So my question is, are you concerned about the impact of weather condition? Because the car we have protected, but the bicycle or electrical bike still exposed to the weather.
Just to repeat myself, there is a weather impact, agreed, but it isn't as massive as those who sit in cars believe. On that front, I can just report as a personal anecdote, I cycled through 2 Wisconsin winters and I survived.
Well, three.
No, I lived through 2 Wisconsin winters.
I
You
lived
did
3.
Great.
Yes. So, but without bike, only walking.
Yeah, okay.
No car, no bike, but feet.
Good. I think there was a last question there.
Yeah, thanks for your presentation.
Sorry.
It would be interesting maybe to extend your study to the impact on urbanism. I think of the concept of a BOD, bike-oriented development, which is a parallel of transit-oriented development. Do you plan to study the impact? And second question concerning your graphic, how does the model split run on your graphic? The new cycling driver users, do they come mainly from cars or not, regarding your graphics?
Okay, thanks. I think the bike-oriented development is an interesting point. We would have loved to do that, but we didn't have the time or the resources. And the idea is available, so anybody can take this up and implement it in his or her city. There's, to help them, the PhD students who worked on this actually have set up a startup firm, so if you need a bit of support with a redesign of your city, you can ask them. So that's the first point. And, where did the change come from? Most of it is change from car. So the car drivers change, and maybe a bit from public transport, but not massively. I don't remember the exact numbers, but it was mostly car drivers changing, which we want to achieve.
Thank you very much. I'd like to invite the next speaker. Thank you for a very interesting presentation.
North American cities?
No.
I'm
Italian.
Yeah, I know, but you said you walked through 3 winters.
Great.
Where?
In Wisconsin, in Madison.
Oh, great.
Madison. Yeah, that was a PhD student there.
Okay, great.
No.
I was just a master's student.
See, I'm not trusted. Yeah. Okay, so Pierre-André, fourth. So, a history of accumulation, stabilization, transport growth in France and OECD countries, Italy included, or
no?
Italy excluded. Yes, only
yes.
France, because we don't talk about stabilization in transport.
Okay.
In Italy, right? No way. Please.
So, good afternoon, everyone. My name is Pierre-André Hort, and I am a researcher at the Matrice Laboratory, CEREMA and CY Cergy Paris University mixed unit based in Lille, France. So today I want to share with you the work we have been conducted with my co-authors Alexandre Rigal, Richard Grimal, and Mathieu Rabot on long-term transport trends in France and across OECD countries. So this work was initially taken with the aim of contributing to the field of transport history by drawing on knowledge and insight from other disciplines related to mobility. Our team comprises urban planners, political scientists, sociologists, economists, and specialists in mobility surveys. So this is the first version of our work, and it was a non-funded research, and we try to do this to learn to work together with different disciplines. So some results can be obvious from some disciplines, but together we try to make a synthesis. So our paper asks a simple question: can we identify any major general trends in transport that might prompt us to reconsider the concept of transition? Sorry. Okay, no problem.
Okay.
Okay. So, it's okay. Souci. So let me start with a theoretical context. Classical historical narratives and a lot of transport policy thinking divide history into ages. So the age of coal, the age of oil, the age of the car for transport. Currently, some people can think about maybe an age of the digital. These narratives rest on a key assumption that new technologies substitute for older ones. So Jean-Baptiste Fressoz, a French environmental historian, has strongly challenged this view in the context of Anthropocene studies. He argues that these narratives overestimate the role of innovations and systematically ignore the persistence of older technologies. For example, more bicycles have been produced than cars globally every year since the early 70s, as the historian David Edgerton reminds us. Transport research can suffer from the same bias, and it's suggested in the introduction of the recent history of French transport between the 19th and the 20th centuries, directed by Louis Baldasseroni, Etienne Faugier, and Claire Pegrims. It tends to focus on competition between modes with the notion of modal shares, substitution, but pay much less attention to their complementarity and coexistence. We propose to shift the lens. So this leads us to two research questions. So first, is the accumulation perspective developed in Anthropocene studies and environmental history more useful for understanding transport history than the substitution perspective? And second, is the accumulation process in transport stable over time, or does it evolve? In other words, is it always more and more and more, to borrow Jean-Baptiste Fressoz's formulation, or do we observe changes in the rhythm of accumulation? So to answer these questions, we combine data from several scales, OECD countries, France at the national level, and 3 large French metropolitan areas, Lille, Lyon, and Marseille. So let me begin to the international evidence at the OECD scale with open access data from the International Transport Forum. So for car ownerships, in most OECD countries, the number of cars per 1,000 inhabitants is converging towards a plateau. So the saturation level varies. The United States leveled off at around 800 cars per 1,000 inhabitants in the early 2000s. The United Kingdom and Sweden followed at around 417 and 500. France reached a plateau more recently in the mid-2010s at around 670 cars per 1,000 inhabitants. Notably, car travel leveled off earlier than car ownership. There is still some growth in the fleet in some countries, but average distance driven is already falling. This suggests that demand for mobility has been saturated before the fleet itself has stopped growing. So for rail, in contrast to car travel, rail passenger traffic has seen a revival in most European countries from the 90s onwards. France, alongside Germany and the Netherlands, stand out with rail travel roughly 5 times higher than in the 70s. Japan, despite very high volumes, shows more limited growth of around 50%. Rail is genuine growth mode in Europe, but even here, growth have been irregular and per capita figures are much less significant than the absolute figures. So here is just a selection of the figures we used in the paper we are currently writing. For air travel globally, air traffic has grown continuously with significant variation across world region. North America has followed a broadly linear growth pattern and remained dominant for decades. However, the Asia-Pacific region overtook North America in the early 2010s. South Asia has seen the most significant relative growth, approximately 50-fold since the 70s. Yet, there are also signs of persistent inequality. Growth has stagnated in parts of Africa, Latin America, and South Asia at relatively low levels. Air travel is one transport mode that has not yet plateaued at the global scale, so it remains highly unequally distributed. Taken together, the international evidence confirms that we will see in France an overall accumulation pattern across all modes, but with road transport converging towards the plateau in the wealthiest countries, rail growing steadily, and air travel still expanding dynamically. So for France, at the national level in France, drawing on the national transport accounts, we see the same broad pattern confirmed across modes. So road traffic grew from 400 to 600 billion vehicle kilometers between the 19th and 2023. We can clearly see accumulation here, but the rate of growth has been falling since the 2000s, and particularly in the 2010s. The main driver of the slowdown is the private car. For rail, we see a similar deceleration, plus a period of stagnation in the 2010s, before a recovery in 2018. Importantly, growth in rail has been driven by high-speed services, partly at the expense of conventional intercity rail, which is one of the few genuine substitution effects we can identify. Per capita, the average annual distance traveled by road stagnated from 2002 onwards, while per capita leveled off in the 2010s. Overall, terrestrial transport growth is now driven primarily by demographic expansion rather than by behavioral change. The trends coincide with the economic slowdown, what economists, notably Summers, called secular stagnation. The significant exception is air travel, which has continued to grow dynamically from 0.66 to 2.76 flights per person per year between 2002 and 2019. Air transport remains the outlier in an otherwise plateauing picture. Before moving to the local scale, a quick word on infrastructures. For example, it's not written here. The French rail network peaked at the late 30s at around 63,000 kilometers and has since contracted to under 28,000 kilometers today. The road network, meanwhile, has been broadly stable since the 50s, and the major decision to halt number of new motorways construction was formalized after the Grenelle Environmental Forum. Maintenance and not construction now dominates transport infrastructure investment in France. So let me finish at the metropolitan scale. Using data from the household travel surveys conducted in Lille, Lyon, and Marseille over several decades by the scientific and technical network of the Ministry of Infrastructure and later Ministry of the Environment, now recently partly by the organization that employs us, CEREMA. For example, one of our co-authors, Mathieu Rabot, is one of the national coordinators for these surveys. Looking at car viability, the picture is telling. All three cities have seen car ownership grow, but the rate of that growth is falling sharply. We can clearly see accumulation. In Lille, the annual increase in the car fleet has dropped from 10,000 additional cars per year to around 3,500 cars per year. In Lyon, from 10,000 to barely 300. And in Marseille, the trend has been reversed. There are now roughly 300 fewer cars per year. When we look at the number of cars per household by urban zone, another pattern emerges. In city centers of all three cities, car ownership is declining. In inner and outer suburbs, the story is more mixed, but the overall trajectory is clear. We are approaching saturation. We can link it to the work about peak car, for example. As for daily kilometers traveled, we see a deceleration across all three cities. Lille still grows, but at barely 1% per year in recent periods, compared to over 4% in the late 80s. Lyon experienced a contraction between the 1985 and 2006, and Marseille also saw a decline in its most recent period. So we should note that the last survey partly overlapped with the COVID restriction in autumn 2024. So how do we explain this pattern? So we propose two complementary explanations. So the first is maintenance. In France, road maintenance required 4 times more resources than road construction in the 2010s. Resources that once went to build new infrastructures now go to preserving the existing stock. This creates a self-reinforcement constraint. The greater the accumulated stock, the greater the maintenance burden, and the less capacity for new investment. As Nelo Magalhães has shown, this applies equally to the rail network. The second is saturation. The car market has likely reached the saturation threshold on most OECD countries. People continue to replace their vehicles, but they are not buying more of them. The marginal utility of owning additional vehicles or of traveling further is declining. In economic terms, transport is shifting from a superior good whose consumption grows faster than income towards a more essential good whose consumption levels off. And then there is the absence of major transport innovation. No new mode of transport comparable to the impact to the car has emerged at the OECD scale. High-speed rail and commercial aviation have continued to develop, but they serve intermittent, long-distance travel and not the daily mobility of most people. Looking ahead, we can sketch 2 scenarios: a business-as-usual scenario in which the current plateau persists as a natural endpoint of one stage of material development, and a disruption scenario in which a radical innovation relaunches accumulation. So our results partially validate the accumulation perspective developed by environmental historians. No major mode of transport has disappeared with a significant exception of the horse. Instead, we have seen the diffusion of new modes, high-speed rail, air traveled alongside the persistence of older ones. But also, we want also to nuance Fresso's account. Accumulation is not constant. It does not simply proceed as more and more and more. The history of transport in wealthy countries over the past 50 years is one of accumulation followed by plateauing. And we argue that this transition between growth regimes is just as historically significant as the phase of rapid growth that preceded it. So let me conclude. Our paper makes 3 contributions. First, we showed that the accumulation perspective can be useful than the substitution perspective for understanding transport history. Over the long run, transport modes accumulate rather than substitute. Second, we show that accumulation is not a constant process. We identify 2 distinct phases: a first phase of rapid growth, characteristic of the 20th century, and a current phase of slowing growth, plateauing, and in some cases, this is decline, particularly in road transport and at the micro level in daily mobility in French cities. Third, we suggest a hypothesis for the most plausible near to medium term scenario: not ecological transition, not degrowth, but stabilization. The growth that persists is concentrated in exceptional intermittent modes, high-speed trains, and especially aviation. Daily transport, the mobility of ordinary people, appears to be entering an era of maintenance rather than expansion. We think that important implication for transport policy, infrastructure investment planning, and for the way environmental historians think about periodization. The transition currently underway is not defined by energy sources, as Fresso's argues for the broader industrial economy. It is defined by growth regimes. So, thank you very much for your attention, and I look forward for the discussion. And but this is we are currently working on this paper, so any improvement can be appreciated. Yes.
Thank you. So thank you for your presentation. And I'm a little bit concerned by the quotation of Summers, because Summers is very pessimistic. And so in the congregation of macroeconomists, he is known as something with someone who is very pessimistic. And for instance, Agion is much more optimistic. Okay. So you can be what you want. Okay. Of course, you can be pessimistic. But to say that the growth stagnation is a fact, is a goal, or can solve the problem of climate change, problem, carbonation, I think it's very naive to do the same thing in the same package. Okay, if we can do something to solve the problem of climate change, we will need a lot of growth to go to the green, to the green production. It will cost a lot. So we need growth to do that. It will be better with growth. If we have stagnation, it will be much more difficult. And then a last point is, what is the criteria? For the growth question, the criteria, the optimal growth is the maximum of consumption you can reproduce. So it's what is sustainable in a certain way. With the climate, with the Earth problem, of course, it's not sustainable now. So you have to think with this criteria. I think the criteria says the best criteria we have now to. So this is
to give you a little context. The first version of the paper was aimed to be published in a journal about Anthropocene and history, and they used a lot the notion of great acceleration. So we wanted to present the fact that in transport there is no currently a great acceleration in terms, but more a saturation. So that's why the yes, yes, really. Yes.
My point would be that growth hasn't stopped, because if you look at shopping, e-commerce has replaced shopping to a large extent, and it has increased the distances involved in it. So I think the story of stagnation would need to be integrating those aspects where the electronic means have allowed us to travel long distance. We had this one speaker today who joined us from wherever. So I think the physical transport doesn't tell the whole story. I guess if you want to tell the whole story, you might want to look at that. And then the story about accumulation and replacement, it might need to look further back. I think Graeber, an Austrian historian, looked at French travel behavior since 1820, and he clearly showed replacement in that period. So I think the 1970s might give you the wrong impression as a starting point.
We use these data because we had the survey in France from this, but it's really interesting because we are currently trying. The first version was not, we were not completely satisfied by the first version, so that's why there is a second which we are currently writing, and this reference can be really interesting for us. Mm. 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 Yes. And we don't have any historian in our team, so that's why it's important to have some insights from. Mm.
Thank you. Any other question? Too much. Otherwise, we can go through to the third presentation. And I invite Alessa Mayer and Andrea Araldo is not here, so it's an intriguing title, Personalized Demand Management for Sustainable Behavior, the Deterrence of Deceptive Agents Due to Preference Elicitation.
Okay, so hello everyone. I'm Alessa Mayer, and I'm going to present to you our work on personalized demand management for sustainable behavior and how preference elicitation can actually deter deception. The work was conducted together with Andrea Araldo, Amir Brutner, and Ravi Seshadri. And yes, so we will use a game theoretical framework. And yeah, okay, a bit about me. I'm a master's student. I worked on this project during my Master 1 internship, and I continued this school year to work on it. Currently, I'm doing something else. I'm doing an internship in a French company, but I'm happy to present to you our work. Okay, so to give a bit of the context, we know that sustainability requires behavioral change. And here's where demand management policies come into play, because they aim to shift individual behavior towards sustainable choices. And there are sources that claim that reducing greenhouse gas emissions can be by more than 40% by 2050. However, the problem is that negative signals like taxes face public resistance and hit low-income households the most. So the solution is to have subsidies, and more explicitly, we will look at personalized incentives based on individual preferences. Here, there still is a problem. For one, the regulator that determines the optimal incentive is slow to elicitate preferences. And also those personalization aspect has a vulnerability to deceptive and manipulative behavior by the agents. However, in our work, we show that the slowness and preference elicitation can actually have a benefit when we look at deception, because it can make the regulator more robust against it. Okay, to just introduce with a simple example. So we have 3 different profiles that choose between taking the train or the car. And we have profile 0, which prefers to take the train, profile 1 that is in between, and profile 2 that is leaning more towards taking the car. And now the question is, as a regulator, how can we best distribute the incentives that we have at hand? Okay, so I will just quickly talk about preference elicitation. So it's the process of inferring preferences from observation of past behavior. And it's used when the regulator has only limited information about the agent's preferences. And in our case, the regulator has no knowledge about the agent's true utilities and only can infer profiles based on the past choices they made. To model the choices they make, we will use random utility theory. And more explicitly, we will have a logit model that has the probability of an agent with systemic utility profile K of choosing alternative I as the following. And the important part here is that the agent has a bias towards the alternative, which brings higher utility for them. And also we account for randomness with a Gumbel scale theta. Okay, so like to our example, so we have 3 different profiles. Yeah, no, we need to formalize a bit. So actually we will look at 2 alternatives, and we simply call them 1 and 2. Just quickly to mention, we are working on expanding it to more alternatives, but now in my presentation, I will consider 2, and also maybe it's easier to explain it like this. So both alternatives have externalities, and we just assume that one of them has more externality than the other, and let's say it is the choice 2, and so the externality is higher than for choice 1. And the regulator thus wants to encourage alternative 1, which is more sustainable, by providing an incentive Y for choosing this alternative and no incentive for choosing the other alternative. This incentive Y should minimize the expected cost, which is simply the sum of expected externality that the agent produces and the incentives. We model the interaction between the regulator and the agents as a Stackelberg game. So each time step, the leader, which is the regulator, will propose a personalized incentive to the agent for alternative 1. And based on this, the follower, the agent, will choose between the two alternatives based on the allotted model that we saw earlier. And after each interaction, the regulator will update their belief on the agent based on the history of incentives and the agent's choice. Okay, so we will look at utility profiles. We have UK profiles. We have N profiles, which are defined as UK, and there is alpha, which accounts for the preferences, X, which is the attribute vector, and the incentive Y, which is Y for choice 1, and no incentive for alternative 2. So actually, we just have two choices, and we don't need the details of the preference vector and the attributes, so we simply convert it to AK for alternative 1 and BK for alternative 2. So the systemic utility of profile UK can be expressed in a simpler form, which is written there. Okay, so from this, the regulator can, for each profile UK, find an optimal incentive. And so the expression is a bit long, but basically we have the max between this expression and 0 because we said we will not tax the agent, we will not make them pay, so it has to be at least 0. And then the maybe important thing is it depends, the incentive depends on the externalities of the two alternatives, on the randomness factor, and also on the preferences of the agents. So this incentive will be higher with higher preferences BK, which accounts for alternative 2, and it will be lower for the preference of alternative 1, which is denoted with AK. So now back to the example. So we have 3 different profiles, and now we look at 2 different ways to infer the preferences, and one is what we call instantaneous preference elicitation. In this scenario, we have self-reporting of the agent, so they will tell us what profile they have, and based on this, they will receive incentives. And so in our example, profile 0 gets the least incentive, and profile 2 gets the most incentive. But here, of course, the question is, why would profile 0 not say, oh, actually, I'm profile 2 to also get the highest incentive? So the agents can report a certain profile. They have to act according to it. They cannot just say, oh, I'm profile 2 and then take the train all the time. But the important thing is they can report themselves and then they will directly have the high incentive. So this means that a deceptive agent who tries to get the high incentive by reporting and acting to another profile can simply calculate if it is good to pretend to be of a different profile, and they have the highest incentive proposed at every step. That means that the personalized incentive policy is vulnerable to deception. And this is actually an assumption made in previous works. So they claim that it's vulnerable to manipulation. Now we will look at another setting, which we call realistic preference elicitation. So this time the regulator will look at the choices, will truly look at the choices the agents made, and based on these choices will determine which profile they are. So the agents have to act according to a certain profile and with the actions convince the regulator of this profile. So maybe it's already like giving an idea. So now it is more difficult to determine as an agent if it's good to pretend to be of a different profile. And also now we are not sure to always have the highest incentive when we pretend to be of a different profile. So we might have a lower incentive. And this means that the personalized incentive policy is more robust to deception. Okay, now we have to formalize. So we get back to our model. For preference elicitation, we use the log likelihood, and the agent's profile will be the one that maximizes this log likelihood based on the observed choice history. That means that simply the regulator will say this, infer the profile which is the most fitting with the past choices. And we actually found a proposition that says that when we compare 2 profiles, and we call this the likelihood gap, or the pairwise likelihood gap, it is strictly bounded. What that means is that an agent who wants to convince the regulator to be of a different profile is bounded and it needs a certain amount of iterations to convince the regulator of a specific profile. So before we had what we call instantaneous preference elicitation, the regulator immediately proposes the higher incentive, and there is no cost for the there's no transition cost for the agent. However, now when we look at realistic preference elicitation, we have this bound. So also the cumulative utility is not fixed, it's not stationary, and the incentive is more of a function of the inferred profile, which evolves over the steps T that are available. From this, we have the theorem where we compare the profitability of deception in instantaneous versus the realistic preference elicitation. And for the honest agent, so of U0 with the lowest incentive, and they truly adopt their profile U0, the expected true utility under realistic preference elicitation is higher than under instantaneous. And for a deceptive agent, so of U0, and they want to have the highest incentive, so they adopt UN-1, the expected true utility under realistic preference elicitation is lower than the expected true utility under instantaneous preference elicitation. So basically, that means that the instantaneous preference elicitation is overly pessimistic for the honest agent and overly optimistic for the deceptive agent. And this bound is what we call the cost of deception. So it's the utility loss from acting to the other profile to convince the regulator, and it cannot be necessarily evened out with the higher incentive. From this, we have the corollary when we compare the scenarios in the instantaneous and the realistic preference elicitation, where it's profitable to cheat. So for scenarios in the realistic preference elicitation, where deception is profitable, they are included in the ones where it's interesting to deceive in instantaneous preference elicitation. However, there are more scenarios where it is interesting to cheat in the instantaneous preference elicitation. Okay, and now we also did a simulation. So we fixed the parameters for externalities and the randomness, and we defined 3 different profiles. So U0 with more preference for choice 1, and U1 in between, and U2 more towards alternative 2. And we did 200 random runs in the Monte Carlo simulation, and we limited the interaction to 15 steps. From the equation that we saw earlier, the regulator can calculate the optimal incentives for each profile, so 0, 3.45, and 7. And so now when we simulate the utility, on the left side, we see the instantaneous preference elicitation, so where the agent directly has the incentive of the profile that they report. And the blue line is the honest, because like they are acting to U0 and they're after U0. And we see that they have clearly less utility than if they pretend to be of U1 or U2 and deceive the regulator. Whereas on the right side, in the realistic preference elicitation, we see that the honest agent actually has more utility at the beginning, and it's not as profitable to cheat. And this, also means that for the social cost, so the social cost is the externality and the incentive that is proposed to the agent. So on the left side, the instantaneous preference elicitation, the agent can deceive the regulator, so the externalities produced are higher and the incentives are higher and the social cost overall is higher. Whereas in the realistic preference elicitation, the agent has no interest to deceive the regulator, so they act honestly and the social cost will be lower. Then we also did some sensitivity analysis. I will show you the one on the externalities. We also have done on other parameters, but yes, so in the square is all the scenarios that we tested, and the crosses mean that it's profitable to cheat. So for 5 time steps, there is no scenario where for realistic preference elicitation it is interesting to cheat. However, for the instantaneous, we see the lower triangle where it is can be profitable to cheat. And when we increase the number of steps, we see that the realistic one, there are more and more scenarios where it's interesting to cheat, and they slowly get to the instantaneous preference elicitation cases. However, this can be interesting to see because it gives us an idea that maybe if we reset the belief of the regulator at some point, or the regulator has to start from scratch again, that maybe it can be more robust, the policy to deception. Okay, so to conclude, the classification uncertainty of the regulator, which is unavoidable, can counterintuitively actually be beneficial, as it can deter deception. We saw that in realistic preference elicitation, deception is more costly for the agent, and that it effectively can reduce it, and that there's a potential for creating robust incentive policies for sustainability via personalized demand management. And we have a preprint on how, and with the QR code, you can access this preprint if you're interested. Thank you for your attention.
So thank you very much. Any question from the floor?
Thank you very much. Some comment. The first one is that, well, when you travel, you are doing different activity. So it depends if you go to workshopping, blah, blah, blah. So I don't say that the preference change, but you behave differently. The value of time is different. So to assume your parameters are constant over time, it's a little bit a limitation, I think. The second, maybe it's like ignorance, but what is the Lambert function? Is the usual function or is some new function I ignore? And third, I was wondering, when you observe individual, when to say you don't know anything about individual, people say, AI know you better than you know yourself. So you know everything about now these days about individual. So, okay, you assume you don't know, but if you observe an individual sometime, in the sense that I do 100 travel a week and you observe 10 choice, then it makes less sense that the individual is strategic in order to pretend to be A when he is B, if he knows that the machine observes some behavior. So in a sense, if the sampling is low enough, the probability to cheat, let's say, it's lower. So this question about I pretend to be another, you don't like what I say, Moshe? You seem... the probability to cheat, as I would call, decrease. So maybe you can respond to one of my questions.
Okay, so yeah, for the Lambert function, so actually, when we, like in the model, when we calculate the optimal incentive, there's no closed form expression. So the Lambert function is a mean to, because we are dealing with exponentials, it's a mean to find some kind of expression, yeah, to have to calculate the incentive. So I don't know if that replies to the question. And then, yeah, for the, so we have limited amount of interaction. So actually, like in the previous work, as I said, like they simplified a bit the interactions, and they had basically no limitation in the interactions, and they didn't consider how what it changes if the regulator really has to infer the profile. So it's true that I think that this parameter, how many interactions are there, is really important to see if deception is useful or not. So I think it's an interesting aspect to consider how like it changes with the number of iterations, but yeah, I didn't show it. And the first question, I forgot.
Thank you.
Hopefully easier. Yeah, Andre's question was too difficult. You assume that there are three profiles, right? And the objective of the regulator is to infer which profile a person belongs to. But the inference is based only on the behavior of a person, of one person. But in reality, I mean, you have a large population. So if in the population, if you only care about is which of the three profile a person belongs to, there are many in the population that belongs to profile 0, many 1, many 2. Some of them cheat, some of them do not cheat. So if you make an inference only on the basis of one person, then they may or may not. But if you make the inference about a particular person based on many other individuals, then maybe the sensitivity to cheating will decrease significantly. You follow me?
Yes. Yeah, this is actually an interesting future research aspect that we also wanted to do, is to consider how multiple agents actually, how it changes the scenario. We chose to focus first on the interaction between 1 and 1, because like in the end, in the simplified setting, the externalities and the social costs are the sum of the individual interactions. So that's why we choose at first to consider one profile, but it's true that when we really consider the influence that have multiple agents, that maybe, it can be interesting to look at that. But for now, we are limited to only one.
So there are no other questions. So it's time for, thank you very much. And it's time for the last paper. So, forgot. Okay, so. Okay. So we now switch gears, because so this is an equilibrium model where we estimated environmental impact of Italy's recovery plan with this general equilibrium model. And this is a joint work with Daniele Cuffari, who's over there, and Lucio Scandizzo, who was here until 2 minutes ago, but he has another paper in another session. So it is as if he's here. And also with Riccardo Magnani instead, who is in Paris. So in any case, so that's the team. And so we'd like to share what the way we are working to come up with an estimate of the environmental impact. And we use this spatial and dynamic general equilibrium model to estimate the overall impact of the National Recovery and Resilience Plan. And we do it at the level of 4 macro regions, 22 sectors, and with some futures that I'm going to share later on. And here what we show is the environmental extension of the core model. And we add an environmental model that links sectoral emissions and water pollution to production levels, energy composition, and infrastructure accumulation. And this enables us to distinguish between three main channels through which public investment affects the environment: a scale effect, a sectoral reallocation, a decomposition effect, and a technological effect. So our objectives were first to say we had to quantify the air and water pollution levels as a byproduct of sectoral production. And then we evaluated the impact of the resilience plan. And then we tried to identify the scale, composition, and technology channels. So the way we worked through this exercise is trying to maintain consistency within the general equilibrium model, not to alter the core optimization problems. So we also try to be parsimonious. So again, without modifying the baseline equilibrium conditions. So, but we were very much interested in reproducing the regional heterogeneity, also to be able to design targeted policies targeted at the regional levels, counting on the differential emission intensities and infrastructure elasticities across Northwest, Northeast, Center, and South Italy. That's one aggregation level. So we were concerned with the pollutants for the air component, carbon dioxide, nitrate oxide, sulfur oxides, methane, and PM10 and 2.5. For the water pollutants, that's actually, I think, a novelty, because usually when we think to the environmental impact, the association is only with air pollution, but water pollution is also very important. And so what we were concerned about is mainly with the eutrophic component of the water pollution, namely the pollution derived by the organic components and the phosphorus and nitrogen element in it. And so this was our concern. Say, we are not aware of any other study about that was concerned about water pollution. There are limits, of course, of what we study, but we really wanted to start putting into the picture also the water dimension. And we start from initial estimates of the levels of pollution using our social accounting matrices that, as you can see, it's too difficult here. So, and that's what we try to do is to build this frame that allows us to get this extended environmental matrix. So I don't get into the details, but it's a linear calculation, but that's the way we start. And then, but you're going to see, one thing is to estimate an environmental impact, and another thing is to estimate the real impact, environmental impact mediated by economic behavior. So we start from here. The matrices come from a spin-off of the University of Verona, the Economics Living Lab. And so we used available public data about the atmospheric emission accounts. These are available for 64 production sectors, the level of detail of these matrices, and 3 household categories. We also gather information about the energy sector disaggregation. We divided, say, within this matrix, we distinguished between the traditional and the renewable energy sector, and one is 40%. The renewable generation ratio is 40%. So that's what we use to have this separation. For the monetary valuation, we use the value of a life year. That we prefer to the value of a statistical life. Both are derived from willingness to pay concepts, but these are the standard figures. Less standards are the figures about the monetary valuation for the value, the willingness to pay, say, to avoid the consumption of a unit of phosphorus or nitrogen. That this evaluation comes from, say, our expert opinion mainly, but there is not a market that reveals this value also. So we think that there is a lot to do to derive these estimates. And then we started from these population equivalent coefficients on 64 sectors, and we started from an article that's the latest one available in Italy, which is this article by Barbiero, Pudu, and Spaziani. So they were reporting these population equivalent coefficients. But then it's like, we forgot about this type of information, and our society was no longer interested in estimating water pollution at the aggregate level. We have many point estimates for each of the lakes in Italy, but we just don't know what the water pollution level is at the Italian level. Now we need to keep in mind that we don't include here the level of microplastic pollution, of FAS, of heavy metals like lead and mercury. So, but having said this, so we came up with estimates, and we were able, say, to learn, say, something about the regional asymmetry of say, the pollution production, let's say, because if we look at the left-hand side here, we see that, for example, the South is responsible for the 19.8 level of production, but we can impute to this production of the South 28.5% of air pollution and 31.1% of water pollution. While, for the Northwest, it's 35.2 and 28.3. So it's relatively lower with respect to the level of output. So I think that what is quite catchy in these figures, and on the right-hand side also, we see that the South is really, in a sense, on the table of the incriminated. So, but the point that we like to underline is that the South generates about 1.4, the national average of air pollution intensity per euro. But we think that its composition, not the energy mix, drives the gap. So also because the renewable share is about 28% in all 4 macro regions. So now, say, this is just to show you the structure of our data that we use as inputs, because the data here, we just show that, say, we simulated a shock in the Veneto region, and then we look at the propagation of it in terms of both air and water pollution. And I'd just like to point out that, say, in this case, 2/3 of Veneto's environmental footprint is exported to other regions. And it would be interesting to see, what happens also if with the shock is applied, say, to Sicily and so. But just to say, we had this information at the Italian level. Also, given our estimates, say air pollution is about, in terms of value, 4 times as large as the water impact. But again, water is just one portion of the whole potential pollution. So, okay, so now we try to say one thing is to estimate an environmental impact, say in a linear, gross way. So we have information about the coefficients, the pollution coefficients, then given the production levels in the economy as described by our input-output metrics, then we estimate the level of pollution. But say that's the scale effect that's described here. So we have the emissions of pollutant P in region R for sector S, which is proportional to an emission intensity. Then, so higher output, higher emissions. Well, is that as simple as that? Well, there is also a composition effect, because we have information, as I showed you earlier, about, say, the non-renewable and the renewable, non-renewable and renewable energy inputs, a fossil emission factor, and a renewable emission factor that offsets the non-renewable one. So changes in energy mix shift emission. So that's important to have these in mind. So it's a composition effect. And then we estimate the social damage, given this social damage weight, which is really an economic parameter. Now, the other key aspect is the technology effect. So we have the scale effect, the composition effect, and then here we can see that K is the infrastructure stock for each region. Alpha bar is the baseline emission intensity, and theta is the infrastructure pollution elasticities. Of course, it has to be greater than 0. But the point is that when we can substitute the baseline, this equation into the baseline, say we have this expression that allows us to interpret this and to really to be able to try to enable us to separate, say, this effect, say the investment, the public investment accumulates as productive capital also increases, but higher capital may reduce emission intensity alpha. That depends on, say, the behaviors, say, of firms, as if the regulatory improvements are appropriate, then firms adopt cleaner technologies so that the technology effect can actually offset the scale effect. So output growth can proceed with falling emissions per unit. So that's what we want to reproduce. Okay, the scale effect, composition effect, that is at work. At the same time, we want to know whether a cleaner technology, how the cleaner technology can mitigate the scale effect. So we are going to have a net effect, which is the balance of these 3 channels. So, okay, so that's what we have in mind. And what we care is about these green multiplier, as we're going to see. So we also care about the welfare integration and environmental taxation aspects and the calibration. But the welfare integration is it depends on what we assume in terms of this environmental, this utility weight, and nobody likes to consume beds. And also the environmental taxation is another important. Here is quite rough, but can be improved. So, it's not trivial though, even though it's quite simple because it affects marginal costs, output prices, a future of our equilibrium model, which is the Tobin's Q mechanism, and that determines the sectoral reallocation through firms optimization. We have other aspects. So we are working also a lot on this calibration, using as best as we can the sources of the data sources that we have available. So, okay, here is a summary of the three effects. So the composition of the environmental effects due to the public investment. We have the scale effect. It's the growth-induced pollution. Higher output from the public investment increases emissions proportionally to the baseline intensity. And this is the dominant channel in sectors without energy transition. For example, the South, the construction sector in the South. Then we have a composition effect. So here are the three effects. And the composition effect, where we have a sectoral reallocation of the energy mix changes. So that's an important element. And then the technology effect, that's the infrastructure-induced decarbonization. That's the interaction term. And captures what we call the green multiplier. Output expands while intensity falls, producing joint gains in GDP and environment. But again, the key is proper, appropriate regulation with the proper incentives so that firms adopt cleaner technologies in an effective and timely way. So the timing is also an aspect that's important because this is a dynamic model. Okay, so the pollution outcomes, we like to point out that the composition effect dominates. Here we have, say, these four sectors that are particularly heavy as sources of pollution. And here we show how that impacts at the level of the northwest of Italy, northeast, center, where we are, and the south. So here's just as an example, the south with respect to the northeast ratio. And so for the northwest, we have a sectoral shock mix where we have a construction increase plus 10% and the services increase of 5%. But that leads to a net CO2 effect of minus 2.1%, where composition dominates. On the other side, the simulated shock on the south, we have a plus 15% on construction, plus 8% on services, which also leads to a net CO2 effect of plus 1.3%. So that's where the scale dominates. So that's one of the main points of our analysis. So now the key insights of our module, environmental module are, and this unified three effect decomposition that we just shared. So the scale, again, composition and technology effects separately identified. Then we have this regional heterogeneity that we model in a structural way. So we're going to see that the north-south divergence in pollution outcomes is going to be maintained in the future, even after the end of the public investment plan. And it stems from differences in energy mix, sectoral composition, and infrastructure endowments, not output magnitude alone. Then the heterogeneity of green multiplier, that's another important aspect. So same euro of public investment produces a different environmental dividend in each macro region. And then flexible policy scenarios, the module supports counterfactual analysis under carbon taxation, green structural transformation, and alternative profiles. So let's see. Okay, these are the main features of our model for macro regions. So we have the 20 regions, but we aggregated to ease interpretation, 22 sectors instead of the initial 64, but then we aggregate also for simplicity, 10 household deciles, 3 type of labor, 4 type of capital, firm behaviors modeled through a Tobin's mechanism. I don't get into the detail because otherwise, so household behavior also is modeled with an intertemporal Euler equation. This is a traditional one, but the mechanism, the dynamics is non-recursive. So the macro closure is Keynesian, otherwise we cannot model, say, the labor market in the north of Italy and the south of Italy are very different, wages are very different. So the other aspect that we model is imperfect competition. So our baseline model starts from the real situation, which is highly imperfect. And then we simulated the gain if we adopt reforms towards greater market competitiveness, especially in the labor market. So this is the model, the core model, and that's the one where we also added the environmental module. So here, just to give you an idea, the glance about, say, the disproportion, say, between, say, the pollution coefficients, say, for the air and water, for, say, for the air pollution, the most polluting sector is the extraction sector. And as you can see, it's about 10 times agriculture, and that's larger than transport. So this is just to give you an idea. There is not that much regional variation. And the same is true for water pollution, but the water pollution is agriculture. That is the tiger. So now this is just to give you some information. And here is our pollution dynamics from 2022 to 2040. As you can see, say this is the construction phase of the public investment plan, and this is the regime phase. And as you can see, when the public investment stops, then there is say the effect tends to stabilize. But what is, say, the pattern is very similar for air and water pollution. And here we have percentage changes in gross output from the baseline. What is underlined is a Keynesian closure. But what we can note is that by 2030, say from now to 2020, when he say this year is the year that that's the final year of the public investment. From this year to the 2030, then we get to this baseline. So both in the northwest of Italy, northeast, and the center, they reach the baseline, while the south remains 3 to 4% here, 3 to 4%. And this is, again, 3 to 4, you see it's slightly higher. The pattern is the same, but the levels are not the same. 3 to 4% above the baseline through 2040. And this is a structural divergence that outlives the public investment stimulus window, which is the one from here, 2022 to 2026. Okay, so the caveats and open research questions are, say, we use fixed emission factors, and that's something that we like to improve on it. And At the same time, also the water index. The water index is just a eutrophication index because it's just limited to the phosphorus and nitrate component of water pollution. But it's very difficult to build regional, national, say in general, aggregate estimate of micropollutants like the FAS or other microplastics, heavy metals like lead and mercury. So we just don't have information, and then there is not a very high correlation between the organic pollution of the water and the inorganic one. So there is research, I think, to be done to be able to come up with aggregate estimates. We do think that it's extremely important. For us, it's quite strange that we've been always associating the environmental impact with simply the air impact, but water is also, of course, involved. The household pollution response too is something that we like to improve as well, and also to see how families react to changes in taxation, and families can be important actor as well, and similarly for also firms. So another aspect is the R&D channel that is also directly associated with the infrastructure development because we really want to understand more how the technology effect operates. So we are trying also to, in the areas where we don't know much, we are trying to complement this information vacuum with artificial intelligence. We like to use also Bayesian techniques to improve the quality of our calibration, and also to use scenario discovery techniques to enrich the analysis that we just shared. Thank you. Any question?
Okay, thank you for the talk. My knowledge in general equilibrium are asymptotically zero, but I was wondering for the water pollution and the air pollution, two things. Why this big hump which finished in 26? So, yes, maybe you explained, but I could not understand because it's, well, 26 is kind of now, so okay, you have recent data, but what explained this big, these two hats? And second, when monetization, air pollution, if you pollute in the middle of the desert, doesn't matter. So it's really, it's an intersection of population and emission. Otherwise, I never understood how you can monetize human life if you don't mix with the population.
Yeah, no, thank you. So the first question is just because here the public investment ends, so there is no, the money injection ends. So that's why there is that jump. And then we have been trying to signal this obvious aspect to the government. Also, say, with our core models, we've been simulating what we call alignment policies. So these public investments comes from European resources. But then, say, the Italian government was supposed to accompany these European investment opportunity with proper accompany actions. And the Italian government didn't perform very well under this aspect. So we don't have this scenario here, but we could show you that. So say the government should have been much more concerned with the fact that it was its duty to sustain this opportunity. That's So say we partly invested, say, this money to favor the energy transition. And that's why we care so much about the technology effect, so that we were able to capture the impact of these, say, target investment. But, you know, so I think that it's would be, I think, a nice opportunity, say, if this model were used also to monitor the activity of the government. But we don't have in Italy this honor to be in dialogue with the government. But that's one point. And the second point was on was related on oh yes, but the point is that, say, we are in Italy, so yes,
you don't have a kind of diffusion model and
no, yes, but in fact, the monetarization is based on willingness to pay type of evaluations. So, and they are, I mean, say these are available, say, for Western societies where there is that are not desert in a sense, but also given this information, we can capture the heterogeneity of the evaluations, if that is was your main concern. But it's a problem of the general system, because the value of life of an extra year of life is something that is embedded and it's in the evaluation process of that is accepted at a Eurostat level. So
you use kind of Coppert model or for the monetization? Which kind of data
actually we use published data. So, but say for water instead, there is a lot of room, say, to evaluate the value, for people, say, to not to consume an extra dose of water pollution. So there is we don't have a reference. So we are really lagging behind. That's what we are trying to point out. We said, let's try to come up with some water pollution estimates as best as we can, and let's try to generate some imitations, say, because it's quite curious. So our debate that doesn't include water pollution.
Thank you. Just a lot of numbers and data. It's difficult to digest all of them at once. But if I understand correctly, I mean, you have PNRR investments over the years for different parts of the country, right?
Yes.
North, center, south, and center. This scheme here, the left side, means that in south, we have an increase in air pollution with respect to the north, because we are constructing more things in the south with respect to the north, right?
Mainly,
yeah,
yes.
I mean, if I understood correctly.
Yes.
But then after that, all the emissions, the pollutant emissions, both on air and water, decrease, at least from the south part. They decrease to a level inferior to the one they had before the PNRR, right?
Oh, yes.
Before the PNRR, it was 6, and at the end, there will be 4, more or less. While in the northern Italy, at least some part of the country will increase, but still stay below the pre-PNRR level.
Yeah.
So on the whole, if I understand correctly, just is my question, the effect of the PNRR in terms of both air and water pollution is positive, in the sense that is reducing pollution at levels which are inferior to the ones they were before the PNRR investment. Is that right?
Yeah, it's positive. And then if you compare it with the north and the center, say that the north and the center,
It's more
catch up,
positive. It's more positive.
catch up, because what we think is that in the south, say this pattern is affected mainly by the scale effect, because composition effects. So the transition from traditional to renewable energy sources is not as strong as in the north, and because of credit market, because of other type of constraints as well, and also the technology effect is much lower. But that means that we really failed to accompany the PNRR, our public investment plan, with appropriate actions that would have favored a more balanced, say, environmental reaction or transition, energy transition, ecological transition in the south. So that is part of the message. But our, say, goal with this research is really to separate these three effects and being able to reproduce, to go to zoom down at a local level, so that we can separate the three effects and really tell an interesting story. So thank you very much. That was. So Lucio is also a co-author. He was supposed to ask questions to ourselves. So now he cannot be mean. But if you have something else to ask, but so that's that's where we are heading. So, and there's a lot of work to do, but I think this is going to be a very rewarding way to go. Okay. So we can go for a coffee. So thank you very much. Thank you for having participated in this session.